I want to walk you through a problem that shows up on the DCA. It's not exactly this problem, but it's similar in that it's got fractional exponents, which can seem really intimidating, but they're really not difficult at all. You can treat a problem that looks like this exactly the same way you would treat any other exponential simplification style problem that we've been doing. You do the coefficients first. 2 divided by 4 is 1/2. So there's a easy simplification step we can do right off the bat. Leaving x to the 1/3, y to the -4, over 2x to the 1/2. And then since we don't know what to do with the fractional exponents just yet, we can do the y to the -4 power. The -4 just creates a reciprocal. So we've got x to the 1/3 divided by 2x to the 1/2 times y to the +4th power in the denominator's position. And now the only real final question, potential problem, is knowing what are we going to do with the x to the 1/3 and the x to the 1/2. And the answer is exactly what you've always done before. Those two terms are being divided. The x to the 1/3 is being divided by the x to the 1/2, which means you're going to subtract the exponents. So you can just come over here to the side and do 1/3 minus 1/2, and you can create a least common denominator or use your calculator, but it really doesn't need to slow you down all that much. This would be 3/6, and instead of 1/3 we would have 2/6. And when I subtract those, I'm going to get -1/6. Numerator minus numerator, denominator stays constant. So -1/6, which means I will have 1 over 2 times x to the 1/6 power times y to the 4th as my final answer. So fractional exponents, when you're simplifying, work the same as whole number exponents. Don't let the fact that you have to subtract, add, or multiply a couple of fractions slow you down.